I've dipped my toe into just the fascinating and vast-scale research that's going on right now about hallucinations. But I look forward to seeing you take us on a deep dive into what the latest research has to say. So would you like to share your screen?
Yes. So let me share my screen. Can you see that?
It's right here. You can see it.
All right.
Okay. Awesome. Thank you very much. I'm going to be back in 30 minutes to check up on you.
Okay, cool. Hello, everyone. Very excited to have this opportunity to share my thoughts around the hallucinations. As Michal just gave a very great wrap-up. So today, I want to present some of our research work on reliable hallucination detection in large language models. So my name is Jiaxin Zhang. I'm a research scientist from Intuit AI Research. Okay, so let me give a brief overview of our company. So if you're from United States, you are familiar with tax and small business. I think you are maybe pretty familiar with our company, our product from like TurboTax, QuickCommerce, QuickBooks, and MailChimp. So overall, Intuit, our target is complete financial confidence. So I highlight the confidence means for financial companies, so the confidence, the trustworthiness, the reliability are very, very critical to our customers. So I think the relationship we build is strongly relying on our confidence and our trust from each other. So and I think before GenAI comes here, Intuit has shifted to want to build like AI-driven expert platform. So to help us achieve financial confidence with TurboTax, QuickCommerce, QuickBooks, one person, one community at a time. And now, so we have I think entered the GenAI zone. So we have built two very impressive products. So I think that's the topic of today is AI for production. So first is we call it AI Assist. It's a generative AI-powered financial assist. So right now, if you log in your either TurboTax, QuickCommerce, or QuickBooks, you will see like the Intuit Assist as a new feature. So now it is a new financial assist that uses the power of Gen AI to give you intelligent and personalized recommendations. So it will do the hard work for you to improve your small business and the personal financial success. So I think that's the product side. I think, again, this accuracy, reliability, trustworthiness in generative AI product are very, very important. So beyond the external product, so we have also this internal product. We call this the platform development. Here we call this Intuit GenOS. It's a generative AI operation systems. So for that one, if you look at, you will see we want to build this platform to accelerate development velocity in the generative AI infra. So here, thanks to our GenOS architect Marine, so we have multiple features and components. So like Gen Studio is the developer sandbox, GenUX is a library of user interface tools, and also like Gen Real-Time, Gen Orchestrator. So an agent tools. We also build is the financial large language models we call Fume. And then again, like I said, it's the accuracy, reliability, and the trustworthiness in generative AI infra also very important. So okay, let's move to the RM reliability side. So for the RM reliability, I think the hallucinations are very, very important and inextricable, because one recent paper they call it a limitation. I think inherent limitation of large language models. So typically we have two types of hallucinations. One is the factuality hallucination. That means like you ask the question about who is the first person to work on the moon, and you may get hallucinant answers. But if you checked online using using some external tools like Wikipedia, you will see, okay, so the correct answer is a different. And another side is the faithfulness hallucination. For example, if you want to summarize the following news article and given this context, and you may generate some answers with some hallucinated informations that you cannot trust it, right? And another type of categorization is like one type of hallucination is the intrinsic, means like directly conflict with the source material, introducing factual inaccuracy or logical inconsistency, right? And another side is the extrinsic hallucinations. That means they're not contradicting, but I think are unfavorable against the source, embarrassing the uncomfortable elements or some additional information that we didn't mention before. So hallucination, I think that the research for this area is very, very active. And if you look at some recent survey paper around this area, I think I just listed this as 3 important survey papers. Most of are pretty recent, from maybe 2022 to 2023, even 2024. So regarding the hallucination, as I think Adam mentioned, the question like, oh, so where is the hallucination? Why we get these hallucinations? So this survey gave a brief, I think is very comprehensive overview of the hallucinations research in large language models from 3 aspects. First is the causes. The causes like hallucination from your data set, and hallucination from your training period, and the hallucination also from your inference. And the second component is the hallucination detection and benchmark. For this part is very important because most of the applied side, we just rely on some business model or black box model like ChatGPT, GPT-4, this kind of models. So we didn't very understand how they handle the data, the training or the inference. So we can just run their model, but we want to detect if it is hallucinated or not in some cases. And also research area want to build this hallucination benchmark to verify, okay, what's the most effective hallucination detection measures, and what's the current status of different models, and what's the accuracy, or what's the performance, right? And the third point is the mitigation. So the mitigation part means once we detect the hallucination, we also want to reduce the hallucination or even mitigate that, right? There are multiple different methods like the data related and the training related and the inference related. I think it's corresponding to the causes in the first component. Here is I just listed this a benchmark using different data set and different methods to test the hallucinations. And the last one I think is from our paper published in the EMRP 2023. And today I will bring you guys with more details. Okay, again, hallucination, I think the talk will cover 2 components rather than the first one, like the causes, but we will mainly focus on the detection and the mitigation part. So the detection hallucination in RM is very, very critical for assess the reliability and the trustworthiness of the generated context. So typically there are multiple ways by defining the metric, like fact-based metric, classifier-based metric, QA-based metric, and also using some uncertainty estimation methods to give an estimate score of your generated content. And also, we may leverage the strengths of different RMs by just prompting the prompting to check the user query and RM generation and define some binary judgment or other roles to give the answer and know if it is hallucinate. And you will know most of these methods are, for example, they will need like some external knowledge or pre-trained models, or define some agent, or using some pre-trained or a lot of additional resources. But in practical, can we pursue one kind of like zero resources methods and can be applied to any different type of models? I think motivated by this requirements, one recent approach proposed, they call it step check GPT. So the target is to propose one kind of zero resources black box detection methods in large language models. So the basic idea is, I think, is strongly motivated by this intuition. So they consider that if LLM has knowledge of a given concept, sampled responses are likely to be similar and contain consistent effects. That means, like, if you ask 1 + 1, in most of the cases it'll be two, right? However, for hallucinated effects, stochastically sampled responses are likely to diverge and contradict one another. That means, like, if you ask a very, very large number and you want to say, okay, can you tell me this number is a prime number or not? So it's hard to say. Maybe each time RM generates different answers. I think that's one is they call it it's a contradictory responses. And based on this intuition, so ChatGPT proposed, like, we want to generate different sampled responses given your query, and want to check this kind of responses are consistent or not. I think this method is also inspired by the self-consistency COT papers before. So, and it's very, I think it's pretty efficient and useful. But we want to re-examine this intuition. It is always true? Probably not, because we observed that, like, solely checking the step consistency of RM is not sufficient for detecting factoriality. So, for example, this illustrative example to show RM step checking. For this case, so you ask the query, like, is pi smaller than 0.2? I think it's pretty classical trick question or query before, but I'm not sure ChatGPT or GPT-4 today, the recent model, have fixed this problem. But you will if you ask this question several times, you will always get the wrong answers. That we call this consistent wrong. So that means the general responses to the same query may be consistent but not factual, right? And another scenario is, like, okay, so the general responses may be inconsistent with the original answer that is factually correct. That means you ask this query and then you start the most deterministic answer by setting the temperature to 0 and get the target answer, and then you generate different samples, want to check if the sample answers are consistent with your target answer. So for this case, you will say, oh, the answer is no, because if we increase the temperature, we may increase the randomness and get a more stochasticness, right? And then we will get a wrong answer. So just rely on the assumption of the ChatGPT, you will get a total wrong answer. So I think that's our key observation. So, and we want to propose some new mechanism to fix this kind of the mismatch or the gap between the true detection performance and the ChatGPT proposed method. And this one is another illustrative example, is for the same query. And we observe that if the query, if this the user query, but if we want to perturb this query a little bit using some semantic equivalent prompt, and if the RM knows this, have the knowledge, they should give the same answer. So first, we perturb this original question and get different answers, but semantic equivalent, and then call RM to answer that. And you will see they will give a different answer. So, and another case is, like, we do not just want to rely on the specific model like GPT-3.5 Turbo or GPT-4, but we want to incorporate a more different model. We call it verifier models, like different type of black box model like BARD, Anthropic Cloud, or even open source model like Llama. So, and for the same query, can we get different answers? So for that case, we check the self-consistency itself, and also, like, the cross-query consistency, cross-model consistency, and also cross-model and query consistency. And then we want to put them together to give you a more comprehensive or assembled assessment of this query and the answers. So based on this insight, we propose this, we call this SCC3, is a semantic-aware cross-check consistency. So we re-examine existing detection approaches based on the self-consistency, like ChatGPT, and then cover two types of hallucinations resulting from the question level and the model level. I think the question level is some kind of, like, if your query is ambiguous or is imprecise, maybe we use some perturbations and get more clear expression such that RM can understand better. And the model level means like we want to leverage the strengths from different pre-trained models and see if we can get more consistent responses rather than just rely on one specific model. And based on this motivation, we propose still sampling-based methods. And I think this method expands on the principle of a self-consistency check. We have a typical 3 stages. One is the question level cross-checking, and then is the model level cross-checking with additional verifier model. And this model can be black box, can be open source models. And the stage 3 is to how to calculate the consensus score and put them together. I think it's all the responses and check the responses are consistent or not with the target response. And here we also propose to combine the query and answer together as a QA pair to check the consistency. And then eventually we put all of them together to define the overall consistency score as a metric to evaluate the consistency degree. And also we incorporate additional model weight hyperparameter because, for example, with specific problem, you may have some high confidence of this model, and you can add a hyperparameter to increase the weight of this model. So now we want to test our performance, and we build this benchmark as the survey paper mentioned. We test 2 types of QA scenarios. One is the classification QA stat, and the task is to determine if its number is a prime number, and the second one is to check this specific people is a senator, a graduate from specific school. And here we compare our proposed methods with the naive self-check GPT, or we call this SC2. You will see our SC3 with all components like the question perturbations and the model perturbations and the cross-check get very great performance and with a significant improvement. So here we incorporated 2 smaller models. One is a Falcon and another is an Organical. But feel free to add the verifier model as you prefer. So I think it's pretty flexible. Another task is the generation QA, means for like HAPA QA or NQ Open, this kind of scenarios. And we also saw very outperformed resource compared with the naive baselines. And also another key question is how many samples do you need? And here we taste a different number of the samples and say, okay, so we may still use maybe 3 to 5 to reduce the cost, but we will get very competitive performance with the larger sample size. I think that's not a big deal. And this one to show the effect of the verifier model with on the final performance. And here is our GitHub. If you are interested, you can just take. And also, we recently released like the first SEC package, means to significantly reduce the cost because it's a sample base, but we can use parallelization like multi-strat strategy to make all the sampling phase to be parallelized, and also like the consistency check is a pairwise to be parallelized. So right now for the hardbox QA, for each query, we can reduce the time from maybe 15 or this kind of time second to just a 2 or 3 seconds. All right, so after the detection, another task is like the hallucination mitigation, means, okay, we detect it's a hallucinate. How can we improve that, or how can I fix that, right? So typically we know like some common use the way like ROC or advanced prompting or some prompt tricks, or either from a model side, we can fine-tune a model or use RHF or choose different models to figure it out. But right now, what we want to do is like, okay, we don't want to rely on external knowledge or make some additional assumptions to make this solution more restricted on specific resources. What we want to do is we still want to propose this kind of zero resources black box methods as a plugin for any type of hallucination detection and mitigation as a whole framework. So here we propose 2 mitigation solutions built on top of the consistency concept, and both are zero resources black box methods. So the first one we call is the RM check and fusion. The inside of this method is kind of like the ensemble. So you will see some related paper like the RM blender, means to leverage different type of open source models and merge them together to give a more reliable answer. So I think that's our related work. And another one is the divide conquer reasoning methods. Means like we want to make the whole long context shorter and shorter, and check the sentence by sentence, and also leverage the strength of LLM with self-correction to further improve the inconsistency to mitigate hallucinations. So first is the scalable consistent ensemble of methods. So the inside, as I mentioned, is kind of like from your input, you send to different LLMs, and it can be black box, can be open sourced, it's fine. And then you will get a bunch of responses. And the next step is how to check the consistency from among each other, right? So here we propose the strategy we call it you only prompt ones. I think it's a new prompt tricks to check the pairwise consistency, but just using one inference to get the consistent resource of query pairs. And then we will get the voting to get the most consistent responses, and also rank the responses from 1 to k. And then eventually we define another step to get a fusion responses to merge them together. I think also leverage the strength of each responses, and also mitigate a potential weakness. For this case, we just want to merge the still far the three models, the 3.5, 4, and the PaLM2. And for this case, we can see our SE methods performs much better than the single use case, specific for this 4 dataset. Here is the meta prompt template for UPO, and also for the fusion component. And for this work, I think it's pretty flexible to incorporate more open source models rather than just rely on black box models. Depends on what's the specific use cases. Okay, the second one is the consistency, DCR consistency. We call it the divide conquer reasoning for consistency evaluation and improvements of large language models. So for this case, like I mentioned in the beginning, another type of hallucinations is from like the summarization task. Means, okay, given this long paragraph, you want to get the short abstract. How can I guarantee there is no hallucinated information extracted from the paragraph? And for this kind of long context comparison where the consistent check is pretty challenge. So that means we propose the objective is to check the consistency between one reference and one candidate. The reference can be your original context paragraph, and your candidate can be the extract abstract or shorter graph. So rather than just direct compare them as a paragraph level, I think if you are familiar with the evaluation metric like GEVAL, this is a state-of-art method for this kind of paragraph evaluations, consistency. So rather than using the paragraph level comparison, we propose this divide conquer solution. Means we define several RM agents. So the first agent is to divide conquer, we call it divide and conquer evaluator. That means that we divide the whole paragraph consistent check to sentence by sentence level, the consistent check. And then the second part is we call this the automatic autometric converter. That means that we want to, based on the sentence level consistent decision and the regions, and come up with a numerical score, and use this score to calculate the consistent evaluation, rather than just say, okay, let RM say, okay, yes or no, or is hallucinated, we're not hallucinated, we're consistent, we're not consistent. So, and then because we use this agent to get a decision, also get some regions. So the regions means like if they are consistent, okay, we say it's fine. But if they are not consistent, we may get some regions. So based on these regions, we want to leverage that and propose a third agent is a region as is a region assisted improver. That means that given this region, can we think about how to improve the candidate to exactly match your reference? So that's what we call is the third agent to improve the candidate or the sentence level and make the consistency with more improvement. I think that's the overall idea, and we have used this method to test like a semantic consistency check and also the summarization task, and get a very significant improvement. That so this just an illustrative example means from the reference candidate, we first implement this one to get the sentence level check and get a consistent or not. And then we use this one to analyze the region and assign score -1 or +1, and then calculate the final score to evaluate this kind of sentence. And then leverage the regions from this agent. We can say, okay, if they are not agent, to see this is green, so we want to use that one to regenerate the new candidate to fit to the original reference. So, and you will see this the whole process is intuitive, and we can implement with multi-round improvement to get more consistent results. Here we show this the benchmark and the experiments. So we outperform the state-of-the-art methods by a large margin. For like the summer eval data set is the very important data set, and we get a very good performance compared with like G-eval, GPT score, or original or conventional score metrics. And also, like I mentioned, this method is not only for consistency check. We also provide this capability for consistency improvement based on the reasoning part. So we significantly reduce near 90% of the output inconsistency. So very promoting for effective hallucination mitigation. So I think that's the results for this 3 benchmarks. So, all right, I think that's all my prepared stuff, but give a brief summary and leave some challenge and open questions. So, as we know, I think hallucination is very, very challenged, is inherent limitation of larger models. And typically for production, we want to implement hallucination detection first, and then try to think about some mitigation ways. And the third one, I think, is consistency is pretty essential and helpful for detecting, evaluating, and mitigating hallucinations. And self-check GPT is a good way, I think, based on the intuitions. But self-check consistency may not be good enough. So that's the reason we proposed SCC3 is a cross-check over questions and model perturbations to get a good performance. And also, we propose 2 solutions of the mitigation solutions. One is the ensembles, another one is divide and conquer reasoning. And beyond that, I think even now we have a bunch of papers, research progress, and the bigger models. We still have a lot of challenges. For example, the hallucination in long-form text generation is a very paragraph level or document level. And also, we have a RAG, is a retrieval augmented generation, but we cannot figure out totally the hallucination, like zero hallucination is impossible in the current stage. So how can I figure it out? And then the third one is the hallucination in like the multimodality, like large vision language models, like Michal showed the case. So it's more challenged than the pure text only models. And also we leave some open questions for discussion. For example, like, can self-correct mechanism help in mitigation reasoning hallucinations? From our case, we say yes, but somehow we still have a small gap, and also the trade-off between the RM cost and the multi-round improvement. And the second is that can we actually capture RM knowledge boundaries? So here, most of the case we focus on like 0 resources and without additional knowledges. But most of the cases like RAG or knowledge graph, we incorporate additional knowledge and the knowledge and it's up to date and now rely on the pre-trained models. Can we make sure all the knowledge are correct and can leverage this kind of knowledge to mitigate hallucinations? So the third one is like, can we strike a balance between creativity and factuality? So that means if you ask some creative question like write a very fantastic or romantic poem, this kind of thing, you don't, maybe some cases hallucinating will be beneficial, right? But for some cases it's not. We want to just get a very rigorous answer and the resource, specifically for domain specific problems like healthcare, financial. So if you just to get a round number, so it will give a big loss, right? So how to trade off the creativity and the factuality, I think this is also very interesting research problem. And here, if you're interested in this kind of work, feel free to look at our paper and also our GitHub repo is for SC3 and the DCR repo we already released online. And finally, let's appreciate my team members. We have Wendy, Damon, Kamalika, and Kumar. They are from Intuit and Intuit AI Research. And this work, we also have the academia collaborators, is Zhang, is a PhD students, and the Brad Malin from Vanderbilt University. So wonderful collaborative work. And thank you, everyone. I think that's it. Any questions? Thank you for your attention and joining this talk.
Nice. Jiaxin, thank you very much. Wonderful talk. However long we have, I'm going to try to get as much out of this, and I'm going to ask you a bunch of questions. I think there's a couple of ones from the audience. Let's see. One of them has to do with different models for GPT. So Slava is asking, have you measured consistency score for different GPT-4 models?
Oh, that's a good question. So the short answer is no, but we noticed this and we want to verify this recently, because so our GPT model, we use Azure API, and we also build a wrapper like the Gen Studio on top of the GPT API. So in our company, we didn't frequently update this version, but we want to try to see the effect of different versions. Like again, for the prime number case, we already noted that the previous GPT-4 version, the results are totally different than the current version. Yeah. So maybe I think OpenAI noticed this kind of thing and fixed the bug. Yeah.
Okay, so until I get other questions from the audience, I want to, people do want to read the paper. Can you scroll up to one of your first slides? I have some questions about that.
This one?
Okay, go to the next one. Next one. Okay, so here we're already beginning to categorize two very different types of hallucinations, right? This is sort of where it seems like we're beginning. You have the factuality hallucination and you have the faithfulness hallucination. Factuality is where the answer that it is giving you is absolutely wrong in the first place, right? We know that it is not factual. Yes. In the faithfulness one, it isn't that it's wrong, it's just that it's not actually relevant to the context that we asked it to collect it from. And so it's misleading, even though it might be true, it's misleading, right?
Right.
Okay, so, okay. Cool. Let's go on to the next one. And also, sorry, and there are going to be different ways of detecting this, right? You can then detect whether or not the hallucination is a faithfulness one versus a factuality one, right? Like the different detection mechanisms are going to help us to parse which one is which, correct?
Yes.
Okay.
Yes.
All right, let's go on to the next one.
Yes. So one comment is like for the factuality, if we can introduce additional external knowledge, that'd be helpful. For example, like RUG, this kind of thing. But for the second one, I think it's kind of like related to some specific task like summarization. So this kind of hallucination may introduce by the extract information from the given reference. Then they will misleading, like you said, misleading some information. So it's a two type of. For this one, maybe the theory sources may be better, but for this one, maybe I think incorporate knowledge will be better.
Okay, so even for the factuality one, it seems to me that there's a possible we can continue to divide this up into different subcategories, because it could be that it simply is lacking the factual information in the network itself, right? Where the fact that was Neil Armstrong was just missing from this model. Or it could be that it actually did know that it was Neil Armstrong, but and so at that point it is sort of like it is inconsistent. So there's inconsistency versus like completion or completeness, right?
Yes, exactly. Yeah, okay. Exactly. So yeah, the proposed method I think is pretty generic to handle different scenarios, But I think if we know some prior information, maybe help us to build on top of the existing methods to figure it out better.
Justin, this was absolutely fascinating. We appreciate you coming here. And a bunch of folks are already going to look at the paper, and they've asked for the GitHub link. So thank you very much for coming.
All right. Yeah. Thank you so much. Yeah.